Okay, today's lessons from the book is lesson 1-4. It's multiplying a power of a power. We're going to review multiplying monomials. That's back what we did 2 weeks ago. It seems like forever almost. We have k to the second, k squared times k to the third, which is k cubed. We end up with k to the second times k to the third equals k to the fifth. And to see that written out, it'd be k, 2k's, k to the second be 2k's. That's k to the 1 times k to the 1 is k to the 2. And again, k to the 1 times k to the 1 times k to the 1. We don't put the 1 there. The 1's assumed. If there's no number there, it's assumed it's a 1. So there's 3 blue k's, that'd be k to the third. And when you get done, it'd be k to the fifth, which is k to 2 plus 3, which is k to the fifth. Okay. What do you think? And go ahead and draw so you don't have to type this out. The exponents is a bit of a pain. What do you think m to the second raised to the third power is? Because now we're multiplying a power of a power. I want you to see how the next to it. Okay, here's what it is. It's m to the second, and you're going to do m to the second 3 times. Multiply it to itself 3 times. M to the second times m to the second times m squared is m to the 2 plus 2 plus 2, which is m to the 6th. Now take a look at the 1 to the left and the 1 to the right. Do you see the difference? That's multiplying the 1 to the left. You're multiplying the same base with different, with the exponents, and you add the exponents. The 1 to the right, you have the base of m to the second, but you're going to raise that to the third power. You're going to multiply it times itself 3 times. Multiplying a power of a power. Let's go through step by step. Draw anywhere on the slide what you think this answer might be. Again, if you're doing this at home and you're not with me during class, you need to pause it. Okay. Okay, start here then. We have 3 n to the third raised to the fourth power. So let's see step by step. That's 3 n to the third times itself 4 times. Now you saw I broke out the 3 in the purple, the n in the orange, n to the third in the orange, because we can also then, through commutative property multiplication, we can move these around however we want. And we can make it 3 times 3 times 3 times 3. And then n to the third 4 times. Then you just start counting. How many 3's are there? Well, there's 4, so that's 3 to the fourth times n to the 3 plus 3 plus 3 plus 3, which would be 3 to the fourth times n to the 12th. 3 to the fourth is 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So it'd be 81 n to the 12th. Again, take a look at that problem. If that's not the answer you got, take a look at that problem and make sense of it. Write down a question. If you have a question, write it down. We're not in class where you can ask me right away, but you can come back to it. You can send me an email, put something in chat to where we can talk about it. When we go to breakout rooms, you can. I didn't totally get what you're saying there. If you're with me in class, you can come back and watch this at a later time. Okay, write your answers using exponents. What's 6 to the second times 6 to the fifth? Go back and check your notes, check the examples we've done, and hopefully you came up with 6 to the seventh. This is not an example. There's no parentheses here. We're not raising 6 to the second. We're not raising it to any power. We're just multiplying 2 numbers with the same base, and we add the exponents. Okay? Now, what's 6 to the second raised to the fifth power? Again, hopefully you've hit pause. You've taken a look at it. You click back on 6 to the 10th. Now we're taking 6 to the second and raising it to the fifth power. We're going to put 6 to the second times itself 5 times. And here's what they look like when they're next to each other. Again, giving you one more chance to look at so you can separate in your brain what the difference between those two problems are. This is where I've seen problems in the past with students. They can't keep these two separated. Explain the difference in the two problems. That's what I need you to do right now. So you have those problems. Explain the difference in the two of them. Okay, you're going to have some work to do. We're going to go to breakout rooms, but before we do, I want to go over a couple of the problems. This will be your second sheet I want you to do. Work on what we did today, the power of a power. Do that first. When you get that done, come back to the multiplying and quotients and products of powers. And here's an example. Go ahead and enter a number. 6 to what power times 6 to the third equals 6 to the fifth. I've got a couple problems like this where you're going to fill in the blank. Not just going to come up with an answer. You're going to figure out what the answer would be. And hopefully you put 6 to the second. On quotients, remember what we do on quotients. On products, we multiply. On quotients, and remember, this page is a review page. Do the first one I have on the slide presentation for you first. But on this one here, for us to get 3 to the fourth, what do we need the numerator to be? 3 to the what power? And again, hopefully you put 3 to the sixth. We're going into breakout rooms, work on the Google Slides. I'm going to give you 15 minutes, and then we'll come back, discuss your answers, and see if we can clear up any problems. Okay, thank you.